Okay, so notice what we were working with there. The expressions I gave you in the examples did not have equal signs. They were just expressions, and all we were doing was simplifying them. Now we're going to go on and talk about things that have equal signs in them. We call those equations. First of all, just what is an equation? An equation is a statement that two quantities are actually the same. And now this is going to sound a little silly, but how can you recognize when you've been given an equation? Well, it's because you will see an equal sign in the problem. Okay. Important to recognize, because there's things you do if you have an equal sign in the original problem that you don't do if there's not an equal sign. And you can't just throw your own equal sign in because you've changed what type of problem you've got then. So it sounds a little silly, but it's kind of an important point to recognize. Okay, here are some examples of equations. 6 over 3 equals 2. 1 equals 5. X equals 7. Those are all equations, right? Because they each have an equal sign. That's how you recognize when you have an equation. But there's one of those that I hope kind of made your skin crawl a little bit when you looked at it. Which one? Yeah, this 1 equals 5. That's a false equation. All right? It's still an equation. It just happens to be false. So an equation, remember, is an equation is a statement. It's a claim. Okay? And you can make statements that are lying statements in math, just like you can anywhere else. Okay? So this statement that these two quantities are the same is a lie. It's still a statement. It's still an equation. This first one, of course, is true. Now, what about this third one, x equals 7? Is that true or false? Well, it depends on what x is, doesn't it? If x is 7, it's true. If x is not 7, it's false. So this one could be true or false, depending on what x is. Now, there's names for these three types of equations. An equation that's true is called an identity. An equation that's false is called a contradiction. An equation that's sometimes true or sometimes false is called a conditional. So it will be true under some conditions and false under other conditions. Okay, so learn those names for those types of equations. What we're mostly going to be concerned with are conditional equations. And what we're going to be wanting to do with them is find out when they're true. So math is a search for truth. That's kind of the big picture of what's going on in math. It's a search for truth. It's not so much a crunching of numbers. It's like I said, it's a search for truth. Okay, so we're going to be searching for when our conditional equations are true. Now in this one, it's super easy, right? If x is 7, it's true. Otherwise, it's not. But as you know from past experience, it's not always that easy. All right. So, all right, going on, a little more terminology. A solution to an equation is a number that makes the equation true. So the solution here would be 7. If x is the number 7, I have a true equation. So, let me finish reading the sentence. It's a number that makes the equation true when substituted in for the variable. So it's the number that the variable has to be to give you a true statement. Okay? And like I said, since math is a search for truth, what we're going to be interested in is finding these solutions, finding out when our equations are true. There's a name for the process of finding the solution. It's called solving the equation. Now, how do we solve equations? Well, first of all, we need to know that two equations are said to be equivalent if they have the same solutions. For example, the following equations are all equivalent. 2x equals 8 Oh, and I know there's no more here. We're going to write some more. But just quick. What does x have to be in order for this to be a true equation? Yeah, x would have to be 4 for this to be a true equation. So any other equation I write where x has to be 4 is going to be equivalent to this one. So like x minus 4 equals 0 would be equivalent to this one. It's not that the two equations have anything to do with each other. They just happen to have the same solution. I don't know, 12 over negative x equals negative 3. For that to be true, x has to be 4. 2x, oh dear, I might be getting myself in over my head trying to make up a complicated one off the top of my head, but let's see. Well, 2x plus 1 equals 3x minus 3. Is that right? 2 times 4 plus 1 is 9. 3 times 4 is 12 minus 3. Okay, yes, so for this one too. If x is 4, it's a true statement. If x is anything else, it's not. And these are all equivalent to the very nice simple equation x equals 4. So notice the more complicated your equation is, the harder it is to see that that's the solution. And the easiest one up here to see that the solution's 4 is this one. So as we're solving equations, our goal is going to be to turn our equation into something this simple. X equals a number. Okay? Again, these equations, it's not that they have anything to do with each other. They're said to be equivalent just because they all have the same solution. And this is the most desirable equation that has that solution because you can just look at it. I mean, it screams at you. X has to be 4. Okay, so how do we get from something like this to something like that? Well, there's a basic principle, and the textbook breaks it down into individual properties of equality. There's an addition property of equality and a multiplication property of equality. But you know what, there's a whole bunch of properties of equality like that, so I'm going to lump them all together in this basic principle that we're going to keep using throughout the whole course. So first of all, in this section of the book, we learn that if you add or subtract the same number on both sides of an equation, the new equation will be equivalent to the old one. In other words, you didn't change what the solutions are. So for example, up here, if I divided both sides by 2, okay, to get x by itself, then I would have this goal equation, right? This would turn into x equals 4. And that's allowed. The basic principle says if you divide by the same non-zero number on both sides of the equation, the new equation will be equivalent to the old one. Equivalent meaning not meaning it's the same equation, but it has the same solution. And just to expand on the basic principle, just to give you a preview, we're going to be learning about more complicated equations, and we're going to extend this basic principle to say it's almost true to say you can do anything you want. I'm going to put in the word almost. You can do almost anything to solve an equation as long as you do the same exact thing to both sides of the equation. Okay, that's what I'm really thinking of as our basic principle. And right now in this chapter, the thing we're doing to both sides is just adding, subtracting, multiplying, or dividing. But we'll build on that and do other kinds of things to both sides too in later chapters. Okay, but that's your basic principle. By the way, also in this chapter, we're focusing on what are called linear equations, and just one way of looking at what a linear equation is that the variable doesn't have any exponent other than the invisible 1 exponent.